Yes, so today's class is about Avl trees. Okay, so in Avl tree is a binary search tree. Okay, so binary search tree, it should have at most two children, right? And I hope remember the concept of binary search tree. It must have at most two children, and your left subtree should be always lesser than the right subtree. Okay, and the root node is considered, and whatever values lesser than the root node will be in left subtree, and the values greater than the root nodes will be in right subtree. For example, if it is 30, and whatever values lesser than 30 will be in left subtree. Okay, and whatever values greater than, okay, root node will be in right subtree. It is not only in root node. Yesterday in lab session, I have asked this question to many, but many of you told it will root node. They have taken only the root node as component, and they have searched left and right. Or they have said that root node is considered for finding the lesser values, to put the values lesser than in left subtree and right subtree, but it is not only in root node. You have to consider all the parent nodes. Okay, so in this tree, okay, this is the first parent, and this parent's left side will be left, smaller values, and right side will have the greater values than the parent node. Similarly, this is a parent of two children, and this node will have lesser values in its left subtree and greater values in right subtree. So remember this thing, and you, okay. So so see this example. So here 40 is greater than 30, so it is in right subtree, and 39 is lesser than 40, greater than 30, so it is in right subtree, but left side of this greater node, parent node. Okay, so think like that and create the subtree. Okay, sorry, insert by insert in binary search tree, because this will always confuse. Okay, so if there are some elements given in your hand to create a tree, the binary search tree, then you have to check each parent node in order to create. Okay, 40, 50, 70, 20 are the sequence. You don't have to sort it, okay, by your own. Come, create as you come. Okay, as the values come. Okay, so first is 40, next element is 50. So 50 is greater than 40, so it will be in right side. Okay, then 70, it is 40. First you have to check with this root node. Okay, so for 70 is greater than 40, so it will be in right subtree, and check with this node. 70 is greater than 52, so it will be in right subtree of this subtree. Then 20, so it is smaller than 40, so it will be in right subtree. Okay, suppose 11 is another node, 9 is another node, so 11 will be in, first you check with the root node. 11 is lesser, so it will come to the left subtree, and check with this node. 20 is greater than 11, that is 11 is lesser than 20, so it will be in left subtree of this parent node. Another is 9. Okay, so first 9 is checked with this root node. It is smaller, so it will be in left subtree. Again checked with this node, that is 20. 20 is again, yeah, 9 is again smaller, so again go to this node. Here also 9 is very smaller, so come and put it here. Okay, don't insert somewhere where that you have space. Okay, suppose another node is 21. Okay, so 21, check with this. Okay, so if it is 21, okay, fine. So 21, check with the root node. It is smaller, so you'll have, you come to this right side, right left subtree. Check with this node. Okay, 21 is checked with 20. It is greater, so it will be in right subtree. Okay, it is not balanced tree. Okay, because since in a complete binary tree you have to balance it, right? You have to put left as possible. Don't confuse with different types of trees. This is binary search tree. Binary search tree will be like this only. Left subtree will be lesser than its parent, and greater than, and the parent will be, the right subtree will be greater than the parent. Okay, so think in this way. Okay, there are many sub binary trees. Okay, binary trees, complete binary tree, heap tree, many trees, but binary search tree is one kind where you will have left subtree lesser value than the right subtree. Please remember this concept, because the today's class we are going to see this Avl tree, right? In this Avl tree, we'll be using this binary search tree concept only. Okay, so the first point of Avl tree is binary search tree. Okay, it is a BST. That is, your left subtree should be lesser than the right subtree. Okay, then in binary search tree. Okay, so we'll see with the I'll show the PPT. Okay, so the time complexity of binary search tree upon depends upon the height of the tree. Okay, so if this tree keeps on increasing in binary search tree, it will be the time complexity of searching. So um, for example, now we have drawn a diagram, right? So it was keep on increasing in this way, right? So if I store some element, some data in this part, if I want to go to the root node, then I have to come left side, left side, left side. I have to do these many hops to find my data, right? If it is only there are four nodes, I'll do four hops to find the data, three hops to find the data. But if it isn't, if there are more than four nodes, if there are more than 40,000 nodes, how many times it will take to find the data? So in order to avoid that time complexity, okay, we are going for AVL tree. Okay, AVL tree is also a binary search tree where it has a self-balancing factor. Okay, so if the factor, okay, so here you will be talking about the word called self-balance factor. Okay, where the balance factor is, okay, factor is 0, -1, and +1, or I can also say -1, 0, and 1 is the balance factor. So each and every time when a new node is inserted, you will be checking the balance factor. Okay, so previously we saw how to insert a node in BST, right? Binary search tree. The same way you will be inserting the nodes in in Avl tree also. But whenever a new node is inserted, you will be checking the balance factor at every time. So the based on the balance factor, you'll rearrange the trees in some order in order to maintain the in order to reduce the height of the tree. Okay, you don't have no need to keep on increasing the left subtree. Okay, see, the right subtrees are very smaller, but left subtree is very larger, right? So in order to avoid this kind of situation, we are going for AVL tree, and ability has balance factor. Okay, so I'll tell you with an example so that you'll understand it very clearly. Okay, so so the balance factor of a tree is, okay, for example, the tree I want to, so the nodes I want to insert is 30, okay, 20, and 10. Okay, so wait, I'll draw. Fine. So the first I want to, so consider this example, 30, 20, and 10 are the nodes that I want to insert in AVL tree. So in AVL tree, you have to check the binary, you should not violate binary search tree property as well as AVL tree property. Binary search tree properties, left side should be lesser than root node, and root node should be lesser than the right side node. Okay, so left, okay, this left subtree should be lesser than the root, and right subtree should be greater than root. And AVL tree property is balance factor. Okay, I'll tell you what is balance factor is. Okay, that is -1, 0, and 1. Fine. So first, okay, so I want to, so this is binary search tree. So insertion in binary search tree is similar to insertion in AVL tree also. Okay, so first I'll take root 30. Okay, so the balance factor is, how you will find the balance factor? Okay, balance factor is equal to height of left subtree minus height of right subtree. Okay, so the balance factors, you have to calculate the height of, what is height of a tree? From that node to the longest leaf. Okay, so height of a tree is, height of tree is, I hope you remember this terminology, or height of a node. Okay, so height of a node is, you have to take from that node to, okay, which node you want to find the height from that node. Okay, or you can also say, or node x. Okay, if I want to find height of particular node, I'm taking that node as x from, okay, node x to longest leaf node. Okay, so this is what your height of a node. Okay, so what how the balance factors consider height of left subtree of that node and height of the right subtree. What is height? You have to take from that node to the its longest leaf. Okay, so here for 30 there is no left. Okay, there is no left subtree, no, there is no right subtree. Okay, so that is 0. Left subtree is 0, right subtree is 0, is equal to 0. Okay, so now we have the balance factor. So this 0 is in the factor of this in this set. Okay, so the balance factor can be a value of -1, 0 or 1. So here for 30 the balance factor is 0, so it is in the, so it is okay. Okay, now I want to insert 20. Okay, so where I will insert 20, so since 20 it will be checked with the first node. Okay, so first point I have inserted 30. Now next is 20. Okay, what how I'll insert 20, it is checked with the 30, that is root node 30. It is less, 20 is lesser than 30, so it will be in left subtree. Now check the balance factor again. So I have inserted the node based on binary search tree. So I have taken this. Okay, now I want to check whether the balance factor is there or not. So what is the balance factor of balance factor of this node? There is no left subtree and left right subtree. So 0 minus 0 is 0 for this node. So you have to check the balance factor of every nodes. Okay, so this for this node, the left subtree is, you have only one node in left subtree and there is no node in right subtree. So the answer is 1. 1 minus 0 is 1. So this also, this value is also in the set -1, 0 and 1. So this is also a proper binary search tree and Avl tree. Now what is the third value to be inserted? 30, 20, and third value to be inserted is 10. So where it will come? 30 is less than 10. Sorry, 10 is lesser than 30. So it will be in left subtree. Okay, so now 20 is another node. I'll check 10 with this node. Still 10 is smaller than 20. So I'll insert in left subtree. Okay, so now check the balance factor. So for this node, the balance factor is there is no left and right, 0. Here you have for this node 20, you have left subtree but no right subtree. So 1 minus 0 is 1. But here for this node, that is root node, the balance factor of left subtree is 1, 2. There are two nodes in left subtree and there is no node in right subtree, which is equal to 2. So here the property is violated. Property of Avl tree is violated. Since it is a binary search tree, but it is not a Avl tree because the balance factor that you got is not in the set -1, 0 and 1. So what do you have to do? You have to do rotations. Okay, rotation. There are 4 different types of rotation: LL rotation, RR rotation, LR rotation, RL rotation. So this thing we are going to see in today's class. Okay, so what is LL rotation? That is left rotation. Okay, which is what is left rotation? You have inserted a node. The problem occurred in for this node, right? This 30 was the face the problem of balance factor. Okay, so balance factor problem was faced by node 30. Why it faced that problem? Because there is a node attached to left of its left, that is left subtree's left side. It is, there is the problem. There is a new node is attached at the in the left subtree's left part. Okay, left subtree's left part. So here you got a problem of LL rotation problem. Okay, so when you a node is inserted in left of left subtree, then that balance factor is violated. Then that problem is, then you can solve that problem by LL rotation. Okay, that is left rotation. Okay, so when you got a problem of LL problem, then you have to do right rotation, that is clockwise rotation. Okay, that is you have to rotate in this way. Sorry, rotate in this way. Okay, so I'll teach you once again. Okay, so you got a problem, right? Fine. So I have inserted root node here, then there is 20, then there is 10. Okay, so my balance factor is violated at this point. Okay, this is the this is the place where I got the problem. Okay, so this is okay, this is okay, but my balance factor is violated at this point, right? So what you have to do here, why the problem occurred? Because you have inserted a new node in left subtree, left subtree, right? So in left side of left subtree. So this is LL problem. So what you have to do, if you got LL kind of problem, you have to rotate in right side or clockwise. Okay, so how you have to rotate? So you just have to pull this down. Okay, so pull right side means you have to rotate in this way. Think that you have these three things in your hand. Okay, I want to pull this down. Okay, these three things are in your hand and I want to pull in or rotate in right side. Because the problem occurred in this node, I have to pull this node in right side. If I pull this node right side, what happens? This 30 will be, okay, will be a down, and 20 will be, okay, sorry, I'll draw it again. Okay, so if I pull this node down, what happens? 30 will be the right side, this will be down, and this will become the center part, and left 10 will be the left part. So think in this way. I want to pull this node down, rotate it in right side, okay, right wise. Okay, so if I rotate right side, what happens? This 30 comes down, 20 will be in middle, and 10 will be in left subtree. Okay, so now check the balance factor again. Okay, so this is 0, this is 0, because there is no left subtree, right subtree. Here also no left subtree, right subtree. What is this balance factor of this node? Left subtree, right subtree. Okay, so left subtree you have one node, right subtree you have one node, 1 minus 1, 0. So the balance factors are minus 1, 0, and 1. So 0 is in the in the set. So your tree is proper binary search tree with Avl tree. So this is what your LL rotation. Similarly, we have three more rotations. I'll tell you with an example, and we'll see a bigger problem to solve in order to find how this rotation works. Okay, so next is so second is 10, 20, and 30. Okay, so 10, 20, 30 are the next element. So what how we will insert? First 10 is inserted. Okay, so this is inserted. The balance factor is 0 because there is no left subtree and right subtree. Similarly, 20 is the next element. So you'll check with this 10. Okay, so where you will insert? Since 20 is greater than 10, so you'll insert it in the right side. Next, again you check the balance factor. So balance factor of 20 is 0. Balance factor of 10 is left. There is no value in left, so 0. There is no, okay. So okay, there is no element in left, so 0. Right side you have one element. So left subtree, height of left subtree minus height of right subtree, right? So minus, no, there is no left subtree, 0. Right subtree you have one element, so minus, so minus 1. So it is also in this set, minus 1, 0, 1 is acceptable, so it is accepted. Next is 30. So you have inserted 20, now 30. Where you will insert? 30 is greater than 10, so in right subtree. Next element, next parent node is 20. 30 is greater than 20, so it will be in right subtree. Okay, right subtree of right tree. Okay, so check the balance factor. There is no left node and right node, so balance factor is 0. Here the for 20 there is no left node, but there is a right node. 0 minus 1 is minus 1. This is also okay. Now for the root node 10, left subtree is 0, right subtree is 1, 2 is equal to minus 2. So this factor is not in the, what was not, is not available in the set, right? So so now what if, now you have encountered problem of RR. What is RR problem? You have the problem occurred in 10. Okay, because 10, on 10 only you have the balance factor is violated. And why you got that violation? Because you have inserted a node and right subtree of right, that is right RR. Okay, so you have inserted 30 at the right subtree of right, so only the balance factor of 10 was violated. So now what you have to do? You have to do RR rotation. So for RR rotation, you have to do left-wise rotation or anti-clockwise rotation. Okay. Please remember LL rotation, you'll do right side. Okay. Or remember clockwise rotation. For RR, you have to do left side or anti-clockwise direction or rotation. So anti-clockwise means this side rotation. Similar way, think there is the, you are trying to pull this 10 down. What you'll do, if I want to pull this 10 down, this 20 will be up. Okay, so I'll draw it again. This, if I'm pulling this 10 down, so what happens? 10 came down. Okay, so if I pull this down, 20 will be the top and 30 will be at the right hand side. So now check the balance factor. Balance factor of this node is 0 because there is no left subtree, right subtree. Balance factor of this also 0, no left subtree, right subtree. And balance factor of 20 is 0, 1 minus 1 is 0. Okay, so now this is a proper AVL tree. So now we have seen two types of rotation, LL rotation and RR rotation. That is, if your node is inserted in left of left subtree, then the balance factor is violated. Then you have to do right side or clockwise rotation. And if you have inserted new node in right subtree, right of right subtree, that is this condition, then then the balance, if the balance factor is violated, then you have to do right, left or anti-clockwise rotation. Next is, okay, so next is, uh, okay, I'll take another example to teach you other two types of rotation. 30, 10 and 20. Okay, so 30, 10 and 20. So 30 I'll insert. Okay, 10 is lesser than 30. I'll insert here, and 20. Okay, so I have inserted 10 and 30. Okay, so now check the balance factor. Balance factor of 10 is 0 because there is no left and right. But for 30, you have left subtree 1, one node in left subtree and no node in right subtree. So it is a 1. Okay, so balance factor is minus 1, 0 and 1. So this balance factor should be from this set only. Okay, so now the balance factor is not violated. So two nodes are inserted successfully. Now what I have to do is, third node to be inserted is 20. So 20 is lesser than 30, so it should be in left subtree. But when you check with this, you will be inserting this 20 in the right of left subtree. Okay, 20 is lesser than 30, so it will be in left subtree. Okay, so here also you have one more parent node. Okay, check with this parent node. 20 is still, it's greater than 10, so you will be inserting this side of the 10, that is right subtree of the 10. So now check the balance factor. Okay, balance factor of this leaf node is 0. Always balance factor of leaf node will be 0. Okay, remember that. Okay, so balance factor of leaf node is 0. Okay, so then now check this balance factor. Balance factor of this node is, there is no left subtree, only one right subtree. So 0 minus 1 is minus 1. It is also accepted for this node. Okay, so for, check for this node. Okay, check for this node. So the balance factor of left subtree is 1, 2. You have to check the height of left subtree. I'm telling you properly, it is height of left subtree. So you have to check the height of that node to its longest leaf. Okay, you should not stop with one step. Okay, so this is, okay, from this node to its leaf. What is the balance factor now? How many nodes do you have in left subtree? It is 2, and there is no node in right subtree. So there are, so the balance factor is violated for root 30. So here, why you got this violation? Because you have inserted the new node in left of left of right subtree. That is, you have inserted a new node in right side of its, this node, the problem node's left side. Okay, so this occurs a problem, this gave you a problem of LR rotation. So you have to do LR rotation. That is, you have to do L rotation plus R rotation. Okay, that is left side rotation plus right side rotation. Where you have to do this L rotation? L rotation in lower part and R rotation in upper part. Okay, I'll tell you. Okay, so you got a problem in on 30. Why you got the problem? Because you have inserted new node 20 in right of left subtree. Okay, left and right. So it is LR rotation. Okay, so if you got LR rotation, then you have to do rotation of rotation in left rotation in right lower part, and right upper R rotation in upper part. So I'll teach you. Okay, so this is the lower part, right? So you have to rotate all three. Okay, so this is your lower part. So in lower part, what kind of rotation you have to do? You have to do left rotation. Okay, here don't confuse with anti-clock and clockwise, just you have to do the left rotation. What is left rotation? How you will rotate this? If 10 and 20 is there, or how you will rotate it? You'll just pull it down. So I'll pull it down likewise. Okay, so after doing left rotation, what how your node looks? Okay, just pull it down left wise. So how, if I pull it down, what happened? 20 will be here and 10 will be here. Okay, so after L rotation, my node will be in this form. Still it is not balanced. I have to do R rotation. So what I have to do? I have to do R rotation. How we will do right rotation? Clockwise. So pull this down. So if I pull this down, 20 will be the top node, 10 will be the left side, and 30 will be the right node. So this is how you will do LR rotation. LR rotation. That is, if your problem occurred in left of right subtree, then you have to do left rotation in lower part, right rotation in the upper part. Please remember, you will be doing rotation oppositely. Okay, so only I'm telling L rotation in lower part, R rotation in upper part. Okay, so I hope you are understanding the class. Okay, still bit it is confusing, but please understand the class, this thing properly. Okay, 10, 30, 20. Okay, so I'll do 10. Okay, balance factor is not violated. 30. Okay, balance factor is not violated. 20, where I'll insert 10. 20 is greater than 10, so it will be in right subtree. But here 20 is lesser than 30, so it will be left subtree. So how you are inserted? So when you check the balance factor is 0, you have 1 and no element in left subtree. So for this node, balance factor is left is 1 node, there is no right node, so 1. For this node, there is no left, okay, minus. But in right side, you have two nodes, okay, so minus 2. So this is not a balance factor, so you have to do some rotation. What kind of rotation you will do? So problem occurred in this node. Okay, why the problem occurred? Because you have inserted a node in left of right subtree. This tens right subtree, you have inserted a node in the left part. So you have encountered problem of RL rotation. So what you have to do? In RL rotation, you have to rotate right side, rotation in lower part. Okay, and left rotation in upper part. That is, this is your lower part and this is your upper part. Okay, so right side rotation in lower part. So if I rotate 30 and 20 is there. Okay, if 30 and 20 are the two elements, if I rotate clockwise, what happens? I'll pull it down. So how will be my this tree will look like? So if I pull this down, 10 will be top. I'm just doing right rotation in 30 and 20 only. So if I pull this 30 down, what happens? 20 will be here and 30 will be here. Okay, now left rotation in upper part. So I have to do left rotation now. Okay, this side. That is, if I pull 10 down, what happens? 20 will be top, 10 will be left, and 30 will be right. Okay. Here, when you check these three, your property of BST is not violated, and your property of AVL also not violated. For AVL, you have to check the balance factor. So balance factor of this node is 0, this node is 0, here also 0, because 1 minus 1 0. And what is the property of binary search tree? Your left part should be lesser than the root node and right part should be greater than the root node. So 10 is lesser than the root node. Yes. 30 is greater than the root node. Yes. So the property is not violated for this tree. Okay. So this is how you will do the rotation. So keep this rotation in mind. We'll do one insertion alone. Okay. I hope you don't have like a class on next start. So I'll take 10 more minutes to complete this entire topic. Fine. Okay, so I'll take an example and I'll help you to solve. So I help you to understand the concept. 14, 17, 11, 7, 53, 4, 13, 12, 8, 60, 19, 16. Okay, I'll cut short this. Okay, this much is enough. Fine. Okay, so if this is the values given to you for inserting in AVL tree. Okay, so in AVL tree you can perform insertion and deletion. We'll see insertion now, and I'll show you example for deletion also. Okay, so first I'll take this first node, that is 14. Okay, I have taken 14. Okay, the balance factor of 14 is 0, so it is inserted. Now next is 17. It is we should follow the property of binary search tree also. So 17 is greater than 14, so it will be in right subtree. Okay, next, so 17 is 17 is inserted. Now check the balance factor. There is no left subtree and right subtree of 17, so the balance factor is 0, because 0 minus 0 is 0. Here for 14, there is no left subtree 0, right subtree you have one element, so minus 1, it is also accepted. Okay, now what is the next thing you have to do? You have to insert. So now this element is inserted. Now you will insert 11. Okay, so 11 is lesser than 14, so it will be in left subtree. Okay, so now check the balance factor again. For 11, there is no left subtree, right subtree, so the balance factor is 0. For 17, there is no left subtree, right subtree, the balance factor is 0. For 14, you have one left subtree and one right subtree, so you have answer is 0. So this is also okay. Now next element to be inserted is 7. Okay. Well, how you insert 7? So first 7 is compared with the root element. 7 is lesser than 14. So it will be in left subtree. Again 7 is compared with the next parent element. Okay. So parent element is 11. So 11 is lesser than 7. So 11 is greater than 7. So 7 will be in the left subtree of 11. Okay. Fine. Okay, so now check the balance factor. For 7, there is no left and right, so the balance factor is 0. For 11, you have one left and no right, so 1, it is also accepted. For this node, you have 1, 2, okay, 2 nodes. The longest, the height of 14 is 2 left side, and right side is 1. So 1, this is also accepted. So the balance factor is not violated. So this is binary search tree and AVL tree. So the next node to be inserted is 5. So where you will 53. Okay, where you will insert 53? Right subtree. Okay, 14. 53 is greater than 14, so it will be in right subtree. And you have another parent node, that is 17. So it is 53 is greater than 17, so it will be in right subtree of right subtree. Okay, next is 4. So where you will insert 4? 4 is lesser than 14, so you'll come to this node. 11 is lesser than 4 is lesser than 14. Again, you'll 4, so you'll go to left, another left side. So it has one more node. 4 is lesser than 7, so you'll insert it here. Check the balance factor. Okay, so here it is 0. For 7, you have 1 minus 0 is equal to 1. For 11, you have 1, 2. 2 minus 0 is 2. So here the balance factor is violated. Okay, if your balance factor is violated for the particular node, don't go after that. Okay, don't have to check for 14. First you solve the problem of this balance factor problem, then you go above. Okay, so the balance factor is violated for the root node 11. Okay, so why it is violated? Because you have inserted a new node 4 in left subtree. Okay, so 11's left side, left, you have inserted new node. So you have encountered a problem of LL rotation problem. So if it is LL rotation, how you have to rotate? You have to do clockwise rotation. Clockwise rotation. Fine. So if it is LL problem, you have to do right side rotation. If it is RR problem, you have to do leftwise rotation. So think this, you have only 11, 7 and 4. If I rotate in clockwise, what happens? That is, if I pull it down, what happens? 7 will be top, 4 will be left side, and 11 will be right side, right? So similar way. Okay, I'm pulling it down. Okay, so same way I'll pull it down. Okay, so if I pull this down, what happens? 14 will be here. Okay, I have, so 17 is same and 53 is same. Okay, it will not change the position. So if I pull 11 down, what happens? 7 will be the top and 11 will be next and 4 will be left subtree. Okay, I'm pulling it down. Okay, so 7 will be here. Okay, so 7 will come here, 11 will go there. Okay, so likewise I'm pulling it, because why I'm pulling in this right side rotation, I'm doing why I'm doing clockwise rotation, because you have encountered problem in ll wise. Okay, when you inserted node at left of left subtree, so you have to do clockwise rotation. So this is my node. Check the balance factor. For the leaf node, the balance factor is always 0. For this node, you have zero, one node left side, one node right side, so 0. And for this node, you have 1 2. Okay, 2 on left side, that is the longest thing, and right side you have 2, so 0. So this is a perfect AVL tree. Okay, so now you have inserted 4. Next, what is the element you have to insert? 13. So 13 is lesser than 14, left subtree, but it is greater than 7, right subtree, but it is lesser greater than 11, so right subtree. Now check the balance factor again. Okay, so what is the balance factor of this node? Always leaf node will have the balance factor of 0. For this node, you don't have, for 11, no left subtree, but you have right subtree. 0 minus 1 is minus 1. And for this 7, you have 1 minus 2. Okay, left side 1 node, right side you have 2 nodes, so it is minus 1. Okay, so this is also okay. So similarly here, you don't have left subtree, but you have right subtree is equal to minus 1. This is also accepted. For root node 1, you have to check the longest leaf. Okay, 1, check the height of that node. Okay, so that is a maximum node, that is the longest path. Okay, you can take this also, but when you check, you have one more. For this node, what is the longest part to the leaf? This is the longest part, this. Okay, so you have to check. Please remember, you have to check the longest part to its leaf. Okay, so for left subtree, 1, 2, okay, 1 node, 2 node, 3 node. 3 minus 2 is 1. 1. Okay, this is also okay. So this is a perfect binary tree plus binary search tree with AVL tree. Okay, now I have inserted 13 also. Now the next node is 12. Okay, same way, 12 where you have to insert. Okay, I'll take this color. Okay, 12 is lesser than 14, so left subtree. It is greater than 7, so right subtree. It is greater than 11, so it's right subtree. And 13 is 12 is lesser than 13, so you'll have it here, right? So check the balance factor again. So always check the balance factor. Don't hesitate to check it, because the balance factor will always, we are keep on balancing in order to reduce the time complexity. Okay, so after inserting, what will be the balance factor of the leaf node? Leaf nodes will be 0. And 13, 1 minus 0 is 1. And for 11, there is no left subtree, but you have right subtree. 0 minus 2. Okay, so here you got a problem. So here the balance factor is violated. Why you got this problem? Because you have inserted a new node in left of right subtree. So 11's right side, you have inserted one node in the left. Okay, so you got RL problem. Okay, so how you have to rotate? You have to rotate RL wise. So right side, lower part, right side, upper part, left side. Okay, so here you have to do, okay, so you have got problem in among these three nodes. In the lower part, you have to do right side rotation. In upper part, you have to do left wise rotation. Remember, please remember, first you have to do the right wise rotation. Okay, how you will do right wise rotation? So right means you have to do clockwise. So if I pull this down, what happens? This 11, okay, so I'll draw the tree again. Erase it. Okay, so I'll draw this diagram. Okay, so 14 will be same, 7 will be left, 17, 53, 4. Okay, so if I, so I'm so 11 will be there. Okay, so if I'm pulling this 13 down, what happens? 12 will be here and 13 will be here. Okay, so like you will have this R rotation. Now you have to do L rotation. So you have problem in this three nodes only. So I have done R rotation. Now I have to do L rotation, that is left notation among these three nodes. How you will do? You will do L rotation in anti-clockwise direction. So what will be the final after rotation? What will be the final tree? 17. These are unchanged. We are not changing these trees, these nodes. Okay, so if I'm doing L rotation among these three nodes, I'll pull this down. Okay, so what happens? 12 will be here. 11 will be here and 13 will be in this side. Okay, so while doing rotation, you'll be getting confusion where to put this node. So insert the previous old nodes. Okay, finally you try to rotate the problematic nodes. Okay, remember. Okay, so now check the balance factor. 0 0 0 0. For this node also 0. For this node 1 minus 2 is minus 1. For this node minus 1. For root node the longest leaf is 1, 2, 3. Okay, 3 minus 2 is minus 1. So now it is a balanced binary tree, balanced AVL tree. Okay, now I have inserted 12 also. Now it is 8. Okay, last node to be inserted is 8. What is 8? How we will insert 8? It is greater than 4, right? So it will be in, sorry, it is 14, right? Okay, okay, it is lesser than 14, left subtree, greater than 7, right of left 7. Okay, but it is lesser than 12, go this side, it is lesser than 11, so you'll insert 8 here. Okay, so check these how to insert. Okay, so I have inserted 8 here. Check the balance tree property, balancing factor. For this node is 0 0. For leaf node always it will be 0, and this node 1 minus 0 is 1. For this node 1 minus 0 is 1. Sorry, it's not 1 minus 0, sorry. Okay, then for this node it is 1 minus 1 is 0. Okay, for this node there is no node, minus 1. For this node it is 1 on. Okay, okay, for this node there is only one node in left subtree. In right subtree you have 1 2 nodes, 1 2 3 nodes, right? Minus 2. So here the balance factor is violated. Which node is violated? You have violation in this node. Okay, so this node your balance factor is violated. Okay, where it is violated, why it is violated? Because you have inserted a node in this of this. Okay, so in right of left side. Okay, so your problem occurred among these three nodes. Okay, so what rotation you have to do? You have to do again, you have to perform RL rotation. Okay, that is right of left subtree rotation. Okay, so how you will do right of left rotation? So you have to perform right rotation in the lower part and left rotation in the upper part. So if I rotate this, okay, so please listen this carefully because this is bit confusing. Okay, so your tree exactly look like that. Okay, after inserting 8. Okay, now your problem, the problem occurred in the root and the node 7. Okay, why? Because you have inserted right of left subtree. Okay, 7's right, left side you have inserted one node, so you have to take the 3 node in order to rotate. So what rotation? RL rotation. So L part, so lower part you have to do right side rotation, right? So fine, so this part you have to do this rotation. Fine, so what, how you will do? You will be just, you have to do right rotation on 12 and 7, 11, right? You just pull it down. So how your node will be? 11, this is 14, 7 will be as such. Okay, okay, 4. So I'm not touching the untouched nodes. Okay, first draw those nodes properly. Okay, now you got problem with 12 and 11. Okay, so 12 I'll pull it down. What happens? 11 will come here, 12 will be here. Okay, and okay, what happens? Okay, now what you'll do, you have to, so don't touch these two nodes because we have to do one more rotation, right? Till that you just keep it. Okay, now if I, among these three nodes I have to do R rotation again. So what happens? 14 will be here. Okay, I'll draw it here. Okay, 14 will be here. Okay, I have to do R rotation. R means I have to do, okay, fine. So I have to do R rotation. Okay, I'm confused. Okay, um yes, I have to do R rotation. I just have to pull this way. Okay, so fine, right. Okay. So yes, I have. If I rotate in this way, finally, how your tree will look like is 14, 11, 12, 7, 8, 4, 12, 13. Here it will be 13, and here 17 and 53 will be. So after doing the RL rotation properly, your tree will look like this. Okay. So uh, I'll give you some more examples tomorrow's class, or I'll try to teach you once again. I know this is a bit confusing than the other trees, but this is how you have to do this avial tree. Okay, so one more thing, I'll just touch with this. I'll I'll tell you how to delete. For deletion also, you have to do these same kind of things where you have to. Okay. Okay, so for deletion also, you have to delete any node. Okay, a node is always deleted to be a leaf node. So after deleting the node, you have to check the balance factor. If the balance factor is violated, you have to do the rotations again. Okay, so remember, you have to delete only the leaf node. For example, if 20, okay, 10, 30, 5, and 15 are the nodes, and I want to delete 30. Okay, so 30 is leaf node, so delete it. Okay, so how your tree will be 20, 10, 5, 15. Check the balance factor. Okay, this is 0, this is 0. For this also it's 0, but for this node, 1, 2, 2 minus 0 is 2. So the balance factor is violated for this node. Why? Because you have, so the problem encountered is left of left, L rotation. So you have to do right side rotation. So after doing right side rotation, this 10 will be the top, 5 will be left side, 20 will be right side. So where the 15 will be? So 15 is right side of 20, 15, right? 15 is right of 10. So you have to go to right subtree. So where you insert 15, because 15 is less than 20, so you insert it here. So after rotation, after deletion, you have to do LL rotation for the particular example. And if you're doing it properly, you'll have this kind of tree. Okay, I'll tell you with another example. Just one more example. Right. One more example. 50, 40, 60, and 45. Okay, so here the node to be deleted is delete 60. So I have deleted 60. So the node will be 50, 40, and 45. Okay, so check the balance factor. Your balance factors will be violated because it is LR. Okay, LR rotation, you know this. So you have to do first R rotation in the lower part. So R rotation means you have to pull it right side. Okay, so 50, 40, and 45. Okay, now you have to do L rotation. So this R rotation. Now you have to do L rotation. So if I pull, so L rotation means I will pull it in right anti-clockwise. So 40 will be the top, 50 will be left side, and 45 will be right subtree. So likewise, you have to do this kind of deletion operation by using AVL tree. You have to use this rotation also. I hope you understood this class. So tomorrow's class, I'll teach again, or I'll give you examples for you to solve this. Okay.